Step inside a modern semiconductor fabrication plant, and you are looking at the most highly automated physical environment on Earth. Wafers of silicon glide along overhead tracks, dropping into multi-million-dollar machines with microscopic precision. But that physical clockwork hides a massive cognitive bottleneck. When a machine deviates even slightly from its parameters, the robots stop. The physical movement is automated, but the reasoning required to diagnose a microscopic defect relies entirely on human engineers. This chart shows a statistical process control, or SPC, monitor, tracking a plasma etch rate. SPC is a quality control method that uses statistical patterns to identify when a process is drifting out of spec. When that line spikes into the red, an alarm sounds, and the equipment halts until someone finds the cause. To fix the drift, an engineer has to manually sift through these layers of fault detection logs. They are parsing thousands of sensor variables, pressure, temperature, gas flow, to find the exact parameter that failed and manually adjust the recipe. Standard generative AI models, like the chatbots used for writing emails, struggle here. Generating a text response is entirely different from analyzing live sensor data and executing a physical adjustment on a lithography machine. Because every anomaly requires a human to investigate and solve it, a fab's maximum efficiency is strictly limited by the cognitive bandwidth of its staff. The industry is trapped on an automation plateau. At the 2026 GPU Technology Conference, NVIDIA outlined a solution, an open-source framework called OpenClaw. OpenClaw functions as the foundational operating system for agentic AI. Unlike a chatbot that waits for a prompt, an AI agent, or Claw, can operate independently. It can navigate file systems, use external tools, and execute multi-step engineering tasks without constant human supervision. This architecture gives developers the tools to build a specialized digital worker. An agent could be trained to monitor those fab sensors, identify process drift, and formulate a solution on its own. But there's a massive roadblock. Semiconductor manufacturing relies on fiercely guarded secrets. Handing an open-source AI model access to proprietary yield data and sensitive machine recipes represents an unacceptable security risk for any fab. Without guaranteed data isolation, even the most capable AI agent remains a non-starter for semiconductor manufacturing. To solve that security problem, NVIDIA announced NemoClaw, an enterprise-hardened version of the OpenClaw framework, built specifically to neutralize that intellectual property risk. The system operates inside an isolated sandbox, wrapping the agent in strict network guardrails. The AI functions at full capacity without exposing data to an external cloud. Safely inside, the agent analyzes live sensor data and cross-references it with historical yield records. When process drift occurs, the agent identifies the root cause and formulates a micro-adjustment. It updates the machine's recipe entirely on-premise, formulating the fix in milliseconds instead of hours. By neutralizing the IP risk, NemoClaw allows fabs to close the loop, turning a massive vulnerability into a secure, closed-loop automation system. To execute these adjustments safely, the agent relies on a digital twin. A digital twin is a physically accurate, virtual replica of a real-world system, powered here by NVIDIA's Omniverse platform, running in exact parallel with the physical fab floor. Before touching a single piece of real equipment, the AI agent tests its proposed recipe adjustment inside this virtual replica. It runs the simulation, observes the physics, and mathematically confirms that the new parameters will actually fix the drift and improve the yield. Only after the solution is verified in the digital world does the agent reach out and apply the updated recipe to the actual physical tool on the fab floor. This workflow is driving a business model shift for equipment vendors towards Agent as a Service, or AaaS. AaaS is a model where customers license autonomous AI agents to perform complex workflows rather than buying static software. Equipment vendors will ship their machines preloaded with specialized NemoClaw agents. These digital workers natively understand the physics and optimal parameters of their specific hardware, continuously optimizing uptime the moment they are plugged in. The human engineer's job shifts from manual data monitor to orchestrator, managing a secure, agentic workforce. By bridging digital simulations with autonomous physical actions through secure agents, the semiconductor fab has evolved into a self-thinking AI factory.